How did oscilloscopes evolve from CRT to digital? Imagine trying to see tiny electrical signals with just your eyes. How did engineers go from that to the high-tech digital tools we use today? Well, it all started with a device called the cathode ray tube. Invented in 1897 by Carl Ferdinand Braun, the cathode ray tube used an electron gun to shoot a beam onto a phosphor-coated screen. When voltage changed, the beam moved, creating a visible trace that showed the waveform. This was the first way to see electrical signals visually in real time. These analog oscilloscopes used this technology to display signals directly, with a trace that moved across the screen as voltage changed over time. They had a vertical and horizontal system to control the shape and timing of the wave, and a trigger system to stabilize repetitive signals. The CRT display was simple but limited by size, bandwidth, and high voltage needs. Usually, these scopes could handle signals up to a few hundred megahertz, which was enough for many applications but not all. As technology advanced, engineers wanted more features and better resolution. Starting in the late 1970s and into the 1980s, the shift began from purely analog CRT scopes to digital ones. Improvements in analog to digital converters, microprocessors, and memory chips made this possible. Early digital oscilloscopes combined the analog front end with a digital recorder that stored signals for later analysis. These early models were not fully digital but set the stage for what was to come. By the early 1980s, fully digital models appeared, like the Hewlett-Packard 1980, which used digital processing to analyze signals. The key change was how signals were captured. Instead of a continuous trace, the input signal was sampled at high speeds using analog to digital converters. These converters turned the continuous voltage into a series of digital data points stored in memory. This allowed engineers to process signals digitally, perform complex measurements, and store data for later review. As the technology improved, sampling rates increased from a few megasamples per second to hundreds of megasamples per second, matching or exceeding the bandwidth of older CRT scopes. The display also changed from the bulky cathode ray tube to modern screens like liquid crystal displays, organic light-emitting diode, and thin-film transistor panels. These new screens are sharper, use less power, and are more compact. They also support features like color coding, persistence modes, and advanced triggering options. From an electrical measurement point of view, this evolution means more precise, flexible, and automated testing. Digital oscilloscopes can analyze complex waveforms, compare signals, and connect to computers for data logging and remote control. This transition from analog to digital has made oscilloscopes essential tools for modern electrical engineering, helping engineers design, troubleshoot, and understand circuits more effectively. So, in simple terms, oscilloscopes started as analog devices using cathode ray tubes to display signals visually. Now they are digital systems that sample, store, and process signals with high accuracy and flexibility, thanks to advances in digital technology and display screens.